Question 13 is all about proportionality. The first part, A, it tells us that y is directly proportional to the square root of x. And we've been given a value for y and we've been given a value for x. So you need to find a formula that links x and y. There's a nice systematic approach to these questions that will always work for you. You can remember that y is proportional to, in some way, this is the symbol for proportionality, the square root of x. Okay. Now this is our maths language way of writing it. This is just this in maths speak, in the symbol speak. So y is 75 and x is 100. What you do with this symbol is when it's directly proportional, direct proportion, you replace this symbol with an equals k. Okay, that is what you replace it with, equals k. So y equals k lots of the square root of x. That's our first step. The second step is to substitute the numbers in that we've been given. So when y is 75, we're talking about x being, or k lots of square root of 100, which is, and we know the square root of 100 is 10, so we can write down 75 is equal to, oh, that's an equal symbol again, doesn't like doing equal symbols for me, 10 lots of k, 10k, because that equates to 10, and we're just going to put the number in front of the letter because it's the conventional way to do things. So we can now work out the value of k by dividing by 10. That's what we want to do. K is representative of the constant of proportionality. It's the thing that connects the x and the y. So we need to find that in each of these cases, and we're going to do that by dividing by 10. Very simple equation, 7.5 is equal to k. And once we've found that, we can put it back in to this bit of our equation, this bit here, this bit of our formula, I should say. So we've got y is equal to 7.5 multiplied by, which we don't write, x in a square root. And that is our formula. That is it. So y equals, it doesn't like equal symbols, y equals 7.5 root x. It can be completed in a similar way, but we've got y is inversely proportional to x squared this time, so it's a different statement. So we can still write it the same way because it's still proportional. So y is proportional to x squared this time, but we're talking about it being inversely proportional. So when it's inverse, we're talking about replacing the little proportion symbol with a k over x. Okay, that's the quick way of thinking about it. So we're going to replace it with a k over x instead. So then we substitute some numbers in, and then we can show that when y is 27x equals 4 using the formula that we're going to create. So y is equal to k over x squared, because we were told it was x squared. What we have to do then is substitute our numbers in. So we've got y being 3. So write 3 instead of y. 3 equals k over, and then we've got 12 squared, which is 3 equals k over 144. Now 144 on the bottom of the fraction there we can get rid of by multiplying by 144. So 3 times 144 is 432. So I've got 432 equals k. The value of k is 432 because I've multiplied both sides of this by 144, and it's left me with k equals 432. Now I can use the value of k, the constant of proportionality, again to show that when y is 27, x is 4. So I can substitute either one of these values in and use k to get the answer. So show that y is 20. Oh, sorry. So show that y is 27 when x equals 4. So I'm going to substitute the value of 4 in, where the x would be in the formula. So I've got y equals, and I want it to be 27, and it will be, the value of k, which is 432, over x squared, which is 4 squared, and then y equals 432 over 16. And if you do 432 divided by 16, you're going to get the answer 27 that you wanted. So y equals 27. And that's a good enough way of showing that y is 27 when x equals 4. 3 marks.